Hi guys, in this video we're going to have a look at shading regions which are defined by these four inequalities. So we're going to start with the easier lines to draw, which is this one and this one. So x is less than 2, we're going to draw the line x equals 2. So, before I make a mistake, this is not including 2, so this is going to be a dotted line. So I'm going to draw a dotted line, vertical dotted line, where x is always 2. And this one is a solid line, it is including the -3, so I'm drawing it roughly to scale. You know, that's 2, that's a little bit bigger, isn't it? That's -3. Let's put some labels on these. 2x plus 2, so we've got a positive gradient, y-intercept of 2. So let's just make it cross that line, because it will, so let's make it look like it is. If you draw it too steep, it's not going to work for this question. So because it's going to cross, make it cross. This one needs rearranging. Let's put it in the form y equals mx plus c. Okay, so -3x minus 1. So it's going to be like, say, there, and a nice steep, well, steeper than the last one I drew. So it's going to cross, so I've made it cross down here. Let's put the label up here. Y equals -3x minus 1. So now what we've got to do is shade the region. I'm going to see if pencil shows up on here, because it's definitely easier to see later on. Now, x is less than 2. So this is where x is equal to 2. So where is x value is always less than 2? Well, that's on this side of the line. You can just about see. I'll do it a bit thicker. Yeah, I think you can see that okay. And for this one, where are the y values greater than -3? Well, they're equal to -3 there, so it must be above, because all the numbers are bigger, higher, larger, whatever you want to say, than -3. It gets a little bit harder with the diagonal line, so let's have a look at this one. So on this line, this is where y is always equal to 2x plus 2. So where are the y values less than 2x plus 2? Well, that's below. We go bigger, we go higher, the y values are higher up here than they are here. If we go lower, the y values is lower here than they are here. So less than or equal to, you can kind of ignore the equal to part, because that's just whether it's a solid line or not. And this one, where are the y values greater than what they are on this line? So higher, above it, we're looking in here. Okay, so where do all these shading sections meet? You should be able to see. So I'm just trying to grab a highlighter. They all meet in this section here. So there is our region. Now, one thing they might ask you to do now is find the vertices. And you've got to be careful with the words, the vertices that are defined by these inequalities. So this point here, right, there are kind of 4 vertices, 4 corners. But this is not a vertex, and this one is not a vertex, because they're not included, because they're on a line that's not included. So we've just got to find out these 2 points here. So to find out this point is where this horizontal line and this line meets. So we can say, let's put them equal to each other, solve them as simultaneous equations. We're going to have 3x is 2, and x to be 2/3. Right. So we've got 2/3. Now we just have to find the y value, and that's easy, because the y is always -3 on that line. These two, a little bit more complicated, because they're both slanted lines, so let's put those 2 lines equal to each other. So we've got -3x minus 1 being equal to 2x plus 2. If you solve this equation, x is on one side, numbers on the other, you get -3/5. Now, let's find the y. So let's use this one, because it's definitely easy to use. We double it and then add 2. So we're going to have -6/5, so that's -1 1/5, and then we're going to add 2 to it, or 2 take away 1 1/5, whatever you want to do, and you get 4/5. So that's how you shade, and that's how you define the vertices. And just don't fall for the trap. If it's on a dotted line, it is not included.